nothing happens except through relations. There would be nothing, and I can show you in the history of the universe, why this is. I can kind of prove that this cosmos is built on a DNA of relationality. Here's what we're doing. We're going to take a journey through this thing real quick with a couple of stops. I'm going to tell the story of the universe, and what I want to be doing is thinking about how continuity, relationality, and entanglement show up as I tell the story. So if there was this Big Bang, we know this because we launched a satellite. It's called the Planck satellite. It sees the world in microwave light. We see the world in visible light. But if you could tune your eyeballs to see in the microwave, you would see what this satellite sees. And we sent it up there, it spins around, and it's taking this video of the entire universe. And when you take that 360-degree spherical view of the universe, you see this image. And then when they process that light and they remove the background noise and they correct for they remove the Milky Way from it, you end up with this image. It's called the cosmic microwave background radiation. It's a picture of the universe, what we would see in the background. So if we could look out there and see the sky out there with our eyes tuned to microwave light, we'd see that pattern out there behind the trees. That's why they call it the cosmic microwave background radiation. So here it is. That's the whole of it. When I saw this as an ecologist, remember that an ecologist is somebody who studies relationships? That's the first thing I saw was relationships. This is 380,000 years after the Big Bang. That's nothing. That's like almost synonymous with the Big Bang. And what do we see? We see relationships. In this case, the colors represent different temperatures, different energy regimes of light. So this is it's an ecosystem of light. When we take a first picture of the Earth, the baby universe, the first thing we see is an ecosystem. I say that because there's these variations in temperature, there's the potential for a relationship between this spot in space and this spot in space. If it had been uniform, nothing would have emerged because there wouldn't have been relationship. The whole thing would have just cooled uniformly. And maybe this has happened. Maybe this has happened countless times. But in our universe, there were these quantum fluctuations that are now serve as the blueprint for the first starry night. Because in these blue regions is where the first stars formed. Because there was less energy there, the hydrogen and helium could come together more readily. So we see a tendency for stars to form in the blue regions. So if you could watch this cool, 13.7 billion years ago, you would have seen the first stars appear in that region. That would have been now we've been through several generations of stars. Stars they're born, they live, and they die. And so the starry night that we see tonight is different, but this would have been the original architecture of a starry night. My point is this: relationality is built into the cosmos. Stars are created, galaxies are created because of the relationality. We should be really seeing things in terms of relationships, not computations. So this is just a sort of schematic of that diagram. So the Planck satellite looks back through time, sees the cosmic microwave background radiation, there's the Big Bang.